Hello and welcome back. Today we'll be doing question 7 from the 2000 Step Paper 3. So, let's get started. Question 7. Given that e is equal to 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial all the way to infinity, use the binomial theorem to show that 1 plus 1 over n all to the n is less than e for any positive integer n. The product p of n is defined for any positive integer n by p of n is equal to 3 over 2 multiplied by 5 over 4 multiplied by 9 over 8 and so on to 2 to the n plus 1 over 2 to the n. Use the AM-GM inequality shown here to show that p of n is less than e for all n. Explain briefly why p of n tends to a limit as n tends towards infinity. Show that this limit L satisfies 2 less than L less than or equal to e. Pause the video to have a think, and once you're ready, restart to see if you were correct. So let's get started with part 1. Here we'll start with the expression 1 plus 1 over n all to the n. By the binomial theorem, this is equal to the sum from r equals 1 to n of 1 over n all to the r multiplied by 1 all to the n minus r multiplied by n choose r, which I've expressed in factorial form. This simplifies down to the sum from r equals 1 to n of 1 over n all to the r multiplied by n minus 1, n minus 2, multiplied all the way to n minus r plus 1, all over r factorial. This is equal to the sum from r equals 1 to n of 1 minus 1 over n, 1 minus 2 over n, all the way to 1 minus r minus 1 over n, all over r factorial. This is less than the sum from r equals 1 to n of 1 over r factorial, and therefore 1 plus 1 over n all to the power of n is less than e for all n that are positive integers, as required. Now let's move on to part 2. By the AM-GM inequality, we have that p of n is less than or equal to the sum from r equals 1 to n of 2 to the n plus 1 all over 2n all over n all to the power of n. This simplifies down to 1 plus 1 minus 1 over 2 to the n over n all to the n, which is less than 1 plus 1 over n all to the n. This, by the previous result, is less than e for all n are positive integers, as required. We can now move on to the final part of the question. P of n is increasing, but is also bounded by e, and so must tend to a limit as n tends towards infinity. Also, p of 3 is already greater than 2, so the limit must be strictly greater than 2 and less than or equal to e, as required. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.